Hello, Synapse community. My name is Ryan Majitimer. I'm a product manager on the Azure Synapse Analytics team. And today we are kicking off a new series on SynapseML. That's right. You might be thinking, well, do we know something about SynapseML? And yes, you do. Our good friend, Mark Hamilton, is going to be joining us again. He's a software engineer on the Azure Synapse Analytics team. We're going to be talking about a lot of topics. It's going to be a very fun series. Going to be talking about cognitive services. We're going to create a multilingual form search engine. We're going to do some OpenAI work. We're also going to use Onyx, talk about what Onyx is. Also, lots of other topics. In addition to that, we're going to have lots of guests. Some guests, lots of guests. Guests, nonetheless, are going to be joining Mark Hamilton in this series. Without further ado, I'm going to hand it over to Mark for him to talk about cognitive services. Welcome, Mark.
Hi, everyone. I'm Mark Hamilton, a software engineer on the SynapseML team, and welcome to the second episode of the SynapseML video series. Today, I'm excited to share with you how to use the cognitive services for big data. This tool allows you to use any of the intelligent algorithms that Microsoft produces as part of the cognitive services at incredibly large scales on your Spark cluster. So let's learn a little bit more. Building a machine learning system from scratch is not fun. It's very complex and difficult and time-consuming. So that's why Microsoft has created a whole bunch of different intelligent services and made them available as products. These intelligent services can do all sorts of things, from understanding what's in an image, to parsing out text and understanding sentences and their semantics, to even listening to speech and being able to transcribe it in real time. The beauty of these cognitive services is that they're general purpose and ready to use. They're very high quality. I've been on one of these teams before, and it's a lot of work. They're just constantly trying to make these things better. And you don't need to train, deploy, or manage anything. You just call it. You just use it. And that's really the beauty here. And it makes using these different intelligent services very simple from a development point of view. And so what we've done is that we've taken all of these intelligent services and we've integrated them into Apache Spark to make sure that all of these services scale to the massive data sets you're used to working with. In particular, we've supported over 50 different intelligent APIs that you can work with on your Spark cluster, and we're adding new ones all the time. So, without further ado, we can head on over to our Synapse notebook and try out a quick demonstration. Today, we'll be giving you a grand tour of using the cognitive services on Spark, from your first, most basic call to all the different fancy features you can turn on to get the most performance out of your Spark cluster. So my first step will be to prepare our imports and keys. Here, I'm just loading our keys from our key vault, and I'm pointing it to our cognitive service in EastUS, but you can replace this with your own details. Once I have our keys in place, we can go on to the basic usage example. Here I've got 3 different images that I'd like to analyze and figure out what they actually depict. The cognitive services on Spark make this fairly easy. I just import the Analyze Image transformer and create a data frame of URLs that point to my images. I can then customize my Analyze Image transformer with my subscription key and location, but also all the things I wanted to extract, like categories, descriptions, faces, objects, tags, and I pointed to this column of URLs in our data frame up above. Applying analyzer.transform, just like any other SparkML model, gets me my results here as a data frame. So we can start by taking a look at what actually gets returned by this service, and we'll see that alongside every single image URL that I fed in, I have a column for errors. Thankfully, there are none, and a column for the analysis results here. So if we click into the analysis results, you'll see a lot of different things in there, from the description to tags to categories to metadata to even objects with bounding boxes. This is all nested as a Spark struct type here, and that allows us to slice out what we need. So if we're just interested in the textual descriptions of these images, we can kick that off and we just pull out the text descriptions for each one of these 3 images. You can see that they're fairly good. So now that we've seen the basic usage, it's time to understand about what's actually going on under the hood and how we can make it a lot faster. So in particular, our Spark cluster has Spark workers, and each one of these workers pick up partitions of data, spin up a little client, and send a request to the cognitive services. This service processes the request, does the actual AI, and sends you back the answers, the responses. Now, ordinarily, your Spark cluster, in its normal, naive parallelism, just breaks up the requests and allows each worker to send requests in parallel. This actually leaves a lot of performance on the table because the majority of the work is being done by the cognitive service, not actually the Spark workers. Ideally, you'd like to make multiple requests while you're waiting on the cognitive service to return an answer to you. So that's why we've added this asynchronous concurrency switch, which allows you to layer your HTTP requests, submitting multiple of them at a time to really maximize your throughput so that the cognitive service is constantly working and the Spark cluster is constantly working. This is a fairly easy thing to turn on. All you need to do is put the set concurrency parameter on your analyzer, and boom, you get the same responses. So in a few seconds, we'll get back the same exact responses we've had without this set concurrency parameter, except that you'll get an extra speed boost with the same exact hardware. You can pull out an extra factor of 10 of throughput just by changing this asynchronous parallelism factor. Next up, we'll see another technique for increasing the speed and the throughput of these cognitive services. Several of these cognitive services, in particular text analytics and that whole suite of services, supports batching requests so that you can send up multiple sentences at a single time. So here is a quick example where I've created a data frame of text here, and I've created a text sentiment transformer. You'll see that it's very similar to the analyze image transformer. It's a SparkML transformer. You point it to the column of text, you give it your location and key, you tell it the output column that you want it to deposit the data into. And in this particular example, we'll set the batch size. So this will allow us to send 10 documents in a single request. So we just increase the throughput of our entire pipeline. And we'll kick this off and we'll see that in a few seconds, we can get back sentiments for each one of these sentences here. And just like the computer vision, this is a fairly good sentiment analysis classifier and you haven't had to train anything yourself. So now that we've shown you two separate ways to optimize your cognitive service pipelines, you might be wondering what happens if the service itself tells you to slow down or can't handle the amount of load that you throw at it. Thankfully, we automatically handle backoffs and rate limiting, and you don't even have to worry about that. The cognitive service bindings will just take care of that. They'll slow down if need be, and they'll retry requests if need be. However, sometimes you really want that extra throughput. You want the performance of, say, 4 or 5 cognitive service accounts in parallel. So in this section, we'll show you how to do that using multiple cognitive service keys. The programming paradigm is quite simple. Here I've loaded another cognitive service key from our key vault. I've created a little array storing our keys, and I've made a quick UDF which picks one of these keys at random. And I've added this as a column to our image data frame here. So now that our image data frame will not only contain URLs, but it will also contain a column called key, which is a random cognitive service key. Instead of setting our subscription key as a single value, we can set the subscription key call here with our column called key. This will allow each individual request to have its own cognitive service key. And because we've randomly assigned these keys, it will load balance across the different cognitive services, allowing you to get even more throughput on your cognitive service pipelines. So with this, you get the same kind of results as you got on the original example, but you can scale it out to 2, 3, 4 times as much. And there's really no limit. You just keep adding keys to this. So to recap, I've shown you how to use 2 different cognitive services, the computer vision service and the text analytics service, and we've explored how you can maximize your throughput by including asynchronous parallelism, automatically batching requests, and using multiple cognitive service keys at the same time. If you're interested in learning more about this project, We have tons of different notebooks like these that show you how to use not just these two cognitive services, but all sorts of different cognitive services. And you can also check out our paper, Large-Scale Intelligent Microservices, to learn even more about the nitty-gritty and how we architected and built this system. Thank you very much for listening today, and we'll put these links and others in the comment section so that you can learn more.
Well, that's great. Thanks, Mark. Again, in our next episode, we're going to expand our knowledge of SynapseML by creating a multilingual form search engine. Tell us in the comments, what kind of ML would you like to know about? I would love to hear about it. Again, my name is Ryan Majitimer. You can find me on Twitter. You can find Azure Synapse on Twitter, Azure_Synapse. You can also find Mark on Twitter, mhamilton723. Also, if you like social media, I have just the program for you. You, sitting right there at your computer, maybe a laptop, maybe what do the kids call it? A tower, a CPU. Never mind. At any rate, social media is the topic we're talking about right now. And if you fancy yourself an influencer, perhaps, we've got the exact program you're looking for, the Azure Synapse Influencer Program. That's right, there's titles, we give away swag, sometimes there's private events. It's very fun. You might be thinking, are the cool kids doing this? And the answer is yes, all of the cool kids are doing this. Very easy to sign up. Link in the description of this video. I, indeed, am an Azure Synapse influencer. Again, you should like, comment, subscribe. Thanks for watching. We'll catch you on the next one.